Hello, YouTube. This is the final episode of the poll series. I had a lot of fun doing it. Thank y'all for voting and watching the videos. Um, this week, y'all voted for read Genesis scientifically. So that is what I'll do now. It's kind of funny ending the series with the beginning. But anyways, let me get started. The 7-day creation account in Genesis tells of a God whose mere word creates a beautiful universe in which human beings are an integral and important part. Modern readers should interpret the creation flood story in Genesis as neither history nor myth. Myth is an unsuitable term for it has several different meanings and connotes untruth in popular English. History is equally misleading, for it suggests that events actually took place. The best term is creation flood story. Ancient Near Eastern thinkers did not have our methods of exploring serious questions. Instead, they used narratives for issues that we would call philosophical and theological. They added and subtracted narrative details and varied the plot as they sought meaning in the ancient stories. Day 1. The Big Bang. In the beginning, when God created the heavens and the earth was without form or shape, with darkness over the abyss, and a mighty wind sweeping over the waters. When cosmic inflation stopped, the energy driving it transferred to light and matter, the Big Bang. 1 second after the Big Bang, the universe consisted of extremely hot, primordial soup of light and particles. In an era called nucleosynthesis, protons and neutrons collided and produced the earliest elements. At this point, though, the universe was still too hot for atomic nuclei of these elements to catch electrons and form complete atoms. The cosmos was opaque because a vast number of electrons created a sort of fog that scattered light. Then God said, "Let there be light," and there was light. Around 380,000 years after the Big Bang, the universe had cooled enough that atomic nuclei could capture electrons. A period astronomers call the Epoch of Recombination. This had two major effects on the cosmos. First, with most electrons now bound into atoms, there were no longer enough free ones to completely scatter light, and the cosmic fog cleared. The universe became transparent, and for the first time, light could freely travel over great distances. Second, the formation of these first atoms produced its own light. This glow, still detectable today, is called the cosmic microwave background. It is the oldest light we can observe in the universe. Day 2. Dark matter halos and the galaxy formation. Then God said, "Let there be a dome in the middle of the waters to separate one body of water from another." When the universe began, regular matter and dark matter were sparsely distributed. Scientists think dark matter began to clump together first, and that those dark matter clumps then pulled together regular matter, creating regions with enough material for stars and galaxies to begin to form. In this way, dark matter determined the large-scale distribution of galaxies in the universe, and by prompting galaxy and star formation to begin earlier than they would have otherwise. Day 3. Star formation. Then God said, "Let the water under the sky be gathered into a single basin, so that dry land may appear." Then God said, "Let the earth bring forth vegetation, every kind of plant that bears seed, and every kind of fruit on earth that bears with it seed in it." And so it happened. Stars form in large clouds of gas and dust called molecular clouds. Molecular clouds are cold, which causes gas to clump. Some of these clumps can collide with each other or collect more matter, strengthening their gravitational force as their mass grows. Eventually, gravity causes some of these clumps to collapse. When this happens, friction causes the material to heat up, which eventually leads to the development of a star. A high-mass star goes further. Fusion converts carbon into heavier elements like oxygen, neon, and magnesium, which will become future fuel for the core. For the largest stars, this chain continues until silicon fuses into iron. These processes produce energy that keeps the core from collapsing. But each new fuel buys it less and less time. This whole process takes just a few million years. By the time silicon fuses into iron, the star runs out of The star runs out of fuel in a matter of days. The next step would be fusing iron into some heavier element, but doing so requires an energy instead of releasing it. Material cast into the cosmos by supernovae and other stellar events will enrich future molecular clouds and become incorporated into the next generation of stars. Pseudopanspermia is a widely supported scientific hypothesis that organic building blocks of life, such as amino acids and nucleobases, formed in space and were delivered to Earth by comets, meteors, and interstellar dust. Day 4, formation of our solar system. Then God said, "Let there be lights in the dome of the sky to separate day from night. Let them mark the seasons, the days, and the years, and serve as lights in the dome of the sky to illuminate the earth." And so it happened. God made the two great lights, the greater one to govern the day, and the less one to govern the night and the stars. God set them in the dome of the sky to illuminate the earth. Our solar system formed about 4.6 billion years ago from a dense cloud of interstellar gas and dust. The cloud collapsed, possibly due to the shock wave of a nearby supernova. When this dust cloud collapsed, it formed a solar nebula. The sun's gravity holds the solar system together, keeping everything in its orbit. The connection and interactions between the sun and the earth drive the season, ocean currents, and climate. Though it is special to us, there are billions of stars like our sun scattered across the Milky Way galaxy. Our moon is the brightest and most familiar object in the night sky. In many ways, the moon is responsible for making Earth such a great home. It stabilizes our planet's wobble, which has made the climate less variable over thousands of years. Day 5, Evolution. Then God said, "Let the water teem with abundance of living creatures, and on earth let birds fly beneath the dome of the sky." God created the great sea monsters and all kinds of living creatures with which the water teems, and all kinds of winged birds. God saw that it was good. And God blessed them, saying, "Be fertile, multiply, and fill the water of the seas, and let the birds multiply on the earth." When scientists first started to classify life, there was eventually came to be 5 kingdoms: animal, plantae, fungi, protista, and bacteria. However, new insights into molecular biology changed this view of life. A type of prokaryotic organism that had long been categorized as bacteria turned out to have DNA that is very similar to that from bacterial DNA. This difference led microbiologist Carl Woese of the University of Illinois to propose reorganizing the tree of life into separate domains: eukarya, eubacteria, and archaea. Archaea is so named because they are believed to be the least evolved forms of life on Earth. The ability of some archaea to live in environment conditions similar to the early days of Earth give an indication of their ancient heritage of the domain. Millions of years after the development of archaea and bacteria, the ancestors of today's eukaryotes split off from the archaea. So although archaea physically resemble bacteria, they are actually more closely related to us. Day 6, Terrestrial Complex Multicellular Life. Then God said, "Let the earth bring forth every kind of living creature, tame animals, crawling things, and every kind of wild animal." And so it happened. Complex multicellular organisms evolved only in 6 eukaryotic groups: animals, fungi, brown algae, red algae, and green algae, and land plants. All multicellular life on Earth evolved from animals, fungi, and land plants over the past 500 million years. Then God said, "Let us make human beings in our image, after our likeness. Let them have dominion over the fish of the sea, the birds of the air, the tame animals, all the wild animals, and all the creatures that crawl on earth." One of the earliest defining human traits, bipedalism, evolved over 4 million years ago. Other important human characteristics, such as large and complex brains, the ability to make and use tools, and the capacity for language, developed more recently. Many advanced traits, including complex symbolic expression, art, and elaborate cultural diversity, emerged mainly during the past 100,000 years.